Hello everyone, welcome back to Dragonfly Engineering. So this week we're going to do a little bit of a beginner's tutorial in CNC machining using this Haas TM1 mill that's about 25 years old, maybe 22 years old. And it's got a tool changer and basically the Haas interface. And this got me started in CNC machining myself. So I'm going to show you some of the self-taught techniques for setting the tools and setting the position of the stock. And the project we are going to do in this episode, which actually I had to break out from a larger episode, is making this huge boring bar for the Stoker Steam engine project with Keith Rucker. So there'll be links in the description for those episodes and that project. But in this episode, we're going to talk about machining this profile on the end of this big steel boring bar, which turns inside diameters of parts on the CNC lathe over there. And we're gonna machine this little receiving pocket for this lathe insert. So hope you enjoy this tutorial and let's get right into it. Okay, so we're over here on the Haas TM1 mill. This is the tool room mill, which is a CNC mill, about 23 years old, and it's got a 10 tool changing turret over here. And I'm going to quickly show the setup of loading our boring bar stock, which again is the scrap test piece of the Stoker Steam engine piston rod, which is 4130 steel, so it's nice and rigid. And we're going to machine in the little profile and the tool holder so that we can turn Keith's steam valve sleeves. I actually did set up a lot of this already, so we can do like a survey of how to set this CNC mill up. It's kind of an entry-level CNC, and I'll show you the easy way to set the tools, or the one way of setting the tool heights and the location of the part, so that it's not overly complicated for beginners in CNC or people who are transitioning from manual to CNC. So let's do it. We got two vices squared up on the table, and I'm going to load our bar into the second vise. And I did actually mount or clamp in the second vise a stock stop, to set the position, because I did actually set this up last night. And but we'll do it again here real quick. So I'll tighten this down using the cantilever of the weight of the rod to kind of set the rod into the vise. I don't have parallels or anything in here. It's just sitting on the bottom, and we'll clamp it down good, but not enough to like mar the surface or anything. And I will remove our temporary stop, and you can actually shuttle your hard stop, which is pretty much the same as a vice jaw clamped on, that clamps onto your vice jaw. Or if you got a second vise, you can just keep loading another piece of stock to set your zero position or the X position of your stock. But we'll pull this out. And right now, over here on the hand controller, there's usually a work offset page, offsets. You click on the offset button. And then the first is the tool heights, so basically when you machine something, you need to know the height of the tool, and then you need to know the location of your stock as it sits in the work envelope of the mill. All right, so we're gonna hit the offset button down on the controller, and now we're in work zero offset. G54 is a G-code command that says this is where your part is. So right now we've got it at minus 15.618 inches for the whole coordinate system of the mill itself. That's basically the absolute position of the table. And then Y is minus 3.754 inches. Z we'll get into in a second. All right, so we're looking at the end of our stock, and I've got the edge finder or the wobbler in here. So what we will do is on the screen, what's the MDI page? Oh, actually, no, we don't even, we need to turn the spindle on. So we can just type in 1200, which is a good RPM for a wobbler, and then hit clockwise. And then our spindle is spinning. Some pages of the CNC won't allow you to turn on the spindle like that, but generally with a Haas you can do it just like that. I'm going to click on the hand jog button, and we're still in the work offset page, and this is where we're setting the location of our stock itself. So I'm going to hit hand jog, and then you set the magnitude of how fast you want to move. So we're going to say 1/1000ths per hand jog click. And then you also want to set the direction. So you've got X plus, or X minus, X plus, Z, and Y. So we're going to move in the X. You just have to hit X and then figure out on your dial which direction you're going to be rolling your part. MDI, and then hand jog again to get out of the tool offset screen, so you can actually see a readout of where you're moving. Then you see that X is moving. So we come down here and we look at our part itself. So with the same technique, I'm going to hit the Z on the controller, 0.01, and then I'm rolling the hand pendant here, and we're going to move Z down. And then I'm going to hit the X direction. I always like to reconfirm the velocity that I'm going to move with the hand wheel. And so I set X 1/1000ths per click, and now I'm moving the hand wheel until we see the wobbler move off axis. So we'll do that again. Here's our wobble, and it just offsets like this. This is just like manual machining. And I'm gonna, with the hand jog, I'm gonna move up in Z now to clear the wobbler off. And now I'm gonna set the motion per click over here on the controller to be 0.1 inches per click. And then I'll hit the X axis. So now X is jogging at 0.1 inches per click of the hand wheel. And this wobbler diameter is 0.2 inches on diameter. So we want to move one radius over. So all we have to do is do one click of the hand wheel, and the X-axis moved 0.1 inches. So right now we're on the edge of that stock. So we'll go back to our control. Now I'm going to click on the offset button, which is right here. And we'll go to the X. And right now, the preset G54 location was minus 15.618. So that's 15 inches in from basically the travel limit of the X-axis of the mill, or the machine coordinate is 15 inches in from the edge of the table, basically. And you can see down here, our X position currently is minus 15.618. So when I found the edge of our stock, it turned out to be exactly in the same position. But I can double check or reconfirm that by clicking on part 0 set. And there it just reset it to minus 15.618. Now we can do the same with Y. And Z is a little different. We'll talk about Z here in a second. Oop, yeah. So now we can do the same procedure with Y. And then the Z axis, actually I usually leave to 0 for the non-probing setup of a CNC, which is more like a manual mill. And we'll talk about that actually right now. All right, so now we're going to talk about the beginner's way of setting tool heights on a CNC mill without the need, or if you don't have a probing system. And a probing system consists of a touch probe that is electronically controlled by your mill, and a little stage or a little surface, a reference surface, that also may be electronically connected to your mill. And you calibrate your probe height. This is not what we're doing, but I'm telling you the way to get around that is if you don't have a probing system that will probe the location of your part, as well as set up and probe the height of all your end mills, then there's a way to do this which is more of a manual machinist way for setting your tool heights. And basically what you wind up doing is you set the height of your tool to be basically the whole height of the column, from the 0 location, which is like at the tool change location, down to your stock itself. So we'll talk about doing that right now. All right, so we are on the the second offset page by hitting, and we got here by hitting the offset button right here on the Haas controller. And this page sets your end mill. Oh, actually no, we're still on the XYZ, the part location. And I've changed Z to be 0 here, and that's kind of important for setting your tools because you want the mill to think that your part location is basically at the 0 height of your mill itself, you know, which is way up here. So if we go to the mill's position, this position right here is Z0, which is basically almost, it's a little bit higher than the tool change height for your Z-axis spindle. You can see on the controller right here, it's an active Z position. Well, we're within 50 thousandths of it. And basically what we're going to do to get around having to have a probe is we're going to define our tool heights to be basically this. Instead of this end mill being just 1 inch stick out, we're going to tell the mill that the end mill is actually like over a foot long. So that our Z0 we don't have to mess with a probing system to find the stock. We'll just have our stock be here, and then our actual part 0 is going to be at the mill 0, which is here. And then all the tools will just be really long, defined in the controller itself. So what we're going to do now is I'm going to hit the offset button on the controller to get into the tool heights page. And you can see our active height is still 49 thousandths off from the mill 0 location, and tool number 7 is highlighted. So then we can go to the MDI page and we'll change the tool to the drill. So we'll say M6T4. M6 is a command that says change tools. I will zoom in on that. And basically M6 says change the tool and then to tool number 4. So M6T4 is the language that the mill understands to actually change out tool number 7 for tool number 4. And we change it out. Now with the Haas, you can also just, if you're in the MDI page, which is manual data input, I believe, you can also just hit T7 and then ATC forward or reverse. Automatic tool change forward. So we'll hit this button and it will do the same thing. So it's a little shortcut, so you don't actually have to write in the little program every time for changing the tool. Now we're going to go back to the offset page, and you can see that tool number 7 in the list is highlighted and the cursor is on tool number 7. You want to make sure that your cursor is on the same line that your active tool is. So it's this one. And now what we'll do is we can hand jog, and we can set the amount of jog. So what I did is I hit the hand jog button, and we're going to hand jog down 1/1000th per click of this wheel right here in the minus direction. So as I turn this knob on the controller right here, you'll see that our tool is coming down. We can make it faster by saying 10/1000ths per click, and then double check your direction. So I hit Z minus, and now we're scrolling down faster to our stock. All right, now we're going to set the tool height to the top of our cylinder using the old-timey manual machining way of holding a piece of copier paper between the tool and the stock and feeling for the paper to get pinched. So you constantly need to move the paper back and forth, and I'm feeling for the paper to get snug and then get pinched by the tool. So that's where we're at right there. This paper is 4/1000ths of an inch thick, which is standard copier paper. So I'm going to click on 1/1000ths per inch, Z minus, and then I'm going to click the wheel 3 times. 1, 2, 3. So I basically pushed 3/4 of the way through this sheet of paper, leaving 1/1000th left. And you don't want to go more because you'll start chipping off the cutting edge of your tool as you kind of plow it into the hard steel. And then on the controller, tool number 7, its location from Z0 is 13.149 inches down from the 0, which is up at the tool change location. So we're going to hit tool offset measure. And now we just set it. And I've already set that tool, so that's a confirmation that it's the same number that I set last time. But the important thing is that if we go to the other offset page, our Z height is set to 0. So when you set all of your tools, so don't mess with Z until you set all your tool heights. And then after that, you can move Z if you need to adjust your part location down. And that's actually what we need to do with this cylinder. So we'll do that next, or right now. So we set all of the tools to this height of the cylinder, but the CNC program is actually referencing the center of the shaft. And this shaft radius is 1.489 is the diameter of our shaft. So 1.489 divided by 2 is 0.7445. So for our CNC program to jive with our mill setup, we actually need to move the part 0 to the center, or minus 0.7445. So what we're going to do on the part setup page of our offsets for the mill, after we set all of our tool heights, I'm going to set Z for G54 to minus 0.7445. Enter. And now we are set up to machine our part. So to recap our little trick here, we set all the tools to a known location on the stock, and so all the tools are set relative to each other to the top of this cylinder, with telling the mill that the Z location of our part is basically at the 0 of the Z axis. So it thinks all of the tools are like 13 inches long now. And then after all the tools were set, we then offset our part Z location from being 0, which is basically right here, to half the shaft diameter. So we dropped it down by 0.744 inches, which basically meant that all of the tool offsets, or all the tool heights, are offset to the center of our shaft now. So just be careful of part location and tool offset location. And I almost always, with this mill, I just set Z to 0 no matter what, and I pick a spot on the part that I touch off all the tools, and I don't mess with the Z location after that. X and Y you can play around with, but Z is the tricky part with CNCs. Now with the 5-axis that we're going to do next for machining the sleeves, it's got an integrated probing system with like a little stage that is touch sensitive, and then there's a probe in the tool changer that is calibrated to an exact depth, and that mill knows, it sets all the tool heights basically relative to the tool setter, and then it also figures out where your part height is relative to the tool setter as well. So it keeps track of things differently, and it's a better way of doing that so that you don't have to reset your tools every time that you have a new project. All the tools in the, here, let me show you. So all of these tools in the 5-axis mill are exactly set to the height of the tool presetter in the milling area itself. Let's take a look at that. So as you get more and more comfortable with CNC machining, you want to use this kind of setup, because your setup for parts is way faster because everything is already set up. You just have to touch off your part, and if the tools are loaded, you know they're set. So ultimately you want to get to this stage, but if you're beginning, you're going to do what we did over there.
All right, so we'll quickly go over the toolpath generation. I use Mastercam CAD, and as we look through the operations on the left, you can see the blue lines indicate the center of the toolpath. So this would be a 1/2 inch, and that's 1/8" end mill that machines the little pocket for our lathe bit. And then we do a profile using the same 1/8" end mill to clean up the edge, followed by a spot drill, and then finally a drill to tap our hole. We're going to manually tap this one just because it's not worth the fuss. But you can also, with these toolpath programs, and again, we're not going to get into that in depth here, but you can simulate the cutting of your part as well. You can play little videos of it so you can really see if you're going to have problems with gouging tools. Here I show the orange overlay of the cut, but then we can, you can turn that feature off, and then I kind of restart it again. So this shows our 1/8" end mill. The 1/8" end mill is kind of tall and spindly because we got to clear the other features. And the nice thing is you can look into see if the flutes or the shaft of your tool is going to gouge, or if your tool holder is going to gouge your metal part as well. But I think I made that tool a little too tall. Anyway, so this is a little bit of toolpath, and we post it out to a disk.
All right, so this mill is so old that it uses the floppy disk to load the program. And it also is kind of finicky about the program name. It can't have a file extension. It has to start with an O and then 5 numbers with no .nc or .txt, just O and 5 numbers. Anyway, but that may not be true for newer Haas mills, but it is for this one. So we put the floppy in, we click the list program, and let's see here, 11/2/25, which is today's date, and then F3 to load it. And it loaded, so that's good to see. All right, so now we'll go to, memory button, MEM, this button right here. And this is our program that Mastercam wrote for us and wrote to the floppy disk. And it gives a lot of material, it gives a tool list. It's kind of a nice setup. And then all the G codes. For instance, tool 7 M06 we talked about, so it's gonna set coordinate systems, change the tool, and then somewhere it'll set G54 for the coordinate system that we set, somewhere in here. Sometimes it doesn't always do it at the top. Oh, there it is, G54. So anyway, let's run it. I think I'll switch out to the telephoto lens and we'll zoom in on the cut. All right, I got you zoomed in to the action, and now I'm gonna reduce the, let's see here, my hand may get in the way. I'm gonna reduce the rapid feed to 25% and the mill's feed rate to, let's say, 50%. And then I'm gonna hit the cycle start button and then be ready with the feed hold button. We're going to cut the clearance profile first. Yeah, that is correct. I'm going to increase the RPM. We're going to do a full face machining with a bunch of reasonably small passes, but I'm going to keep the feed rate low just so that we don't do anything bad. I'm going to turn the coolant on because we are cutting kind of hard steel here, so hit cycle start. Our first pass. I've got everything going slow here because this is our first cut, our initial setup. Electricity rate in the jog. The total power is at 25%. My tool height is right at the max, actually. I think we're almost done with that. No, we got to finish that. Okay, and now we're going to change to our second tool. And this is going to cut the cutter profile. Oop, and off it went. Oh, I think I had the feed too high. All right, you got to reset. All right, we are done with that cut. We're going to change tools. And I will slow everything down. For our center drill. There we go. Okay, now for our pilot hole for M4 tap, which will hold the tool insert into our little diamond pocket that we made. Again, I'm being very conservative about everything because we just need it to cut the first time and work the first time. We're not in production here. There we go. I'm going to stop the program there so that we can stick a tap in this coaxial position. I'll probably change the tool back to tool 5, and then we'll put a spring-loaded tap follower in, and then we'll tap out our hole for the thread insert. So we'll bring the Z-axis down. Try not to block the camera. And we'll put our tool in the hole there in the bottom. And get it lined up. There we go. And then we'll give ourselves some travel with the spring-loaded plunger. And now we are aligned. And I can tap our hole. Now you do have to follow the tap handle because you don't want the center hole to get out of the spring-loaded plunger center post. And we'll hand tap this. You don't have to do everything CNC. You can, with an open frame mill like this, which I don't think Haas sells anymore due to lawyers, you can do manual machining techniques with your CNC mill like this. You know, because I don't want to go through the fuss of getting feeds and speeds just right for this super hard steel. And I have a kind of a tight pilot hole because I want a reusable thread here for future uses. So I'm gonna kind of baby this threaded hole and back it out a bunch. If you just rely on the rigid tapping that the CNC, a lot of CNC's mills do, they're not as forgiving sometimes, and you need like a bigger pilot hole for steel with a 50% thread exposure, and this is more like a hole for an aluminum with a 75% thread exposure. So I'm just doing like a little mouse bites, backing it out, going back in, another little mouse bite. And having this tap follower, keep your tap perfectly in line, also helps prevent you from snapping off your tap by bending the tap off axis basically while you're trying to turn it. And you can measure how far in you've gone, sort of, with how much your spring-loaded pin is exposed out of the spring-loaded shaft. So you can get a little more torque on the cut than you would otherwise be comfortable with, depending on how many taps you've broken in your day. I've broken a lot of taps earlier in my career, so I also don't want to jinx this, so I'm just gonna be quiet now. But twisting this way or this way is like really bad for your tap, because it magnifies the stress down where it's going to break off. Axial torsional stress, doesn't build up as much. Eventually you find the bottom. I didn't drill through because I didn't want to bust off the tip of the drill bit when you break through like a crazy corner like that down here at the bottom. If I do break the tap, I can EDM it out with the RAM EDM tool, so electric sparks would eat away what's left of the tap. But I think I've hit bottom. It's definitely springing there. Okay, so now we'll back out. And you got to raise up your spring plunger at some point so you can get your tap back out of the hole. It's best not to disengage it. Okay, there we go. I think we are done with our lathe bit boring bar. All right, there it is. See if the screw fits. All right, so far, so good. You hear any snapping carbide bit when I tighten this down. Okay, it's in there. I think we're done. Look at that. All that work just to hold that little tool out there.